ahead. Hey, I spotted an enemy vehicle, over.
Oh yeah! I'm killing all these thuds!
For fuck's sake! Oh my god! I scared the crap out of you, didn't I?
Get away from my TV! Let me play my game. And who are you anyway?
I'm you from the future, actually.
That doesn't make any sense. You have a round face.
Well, you go to a plastic surgeon.
Oh, so I do end up going, huh?
Mm-hmm. Anyway, I want to tell you something important that'll help you in your future.
Really? What is it?
Well, you see, I want to talk to you about spectroscopy.
Oh, thank God! I have to make a video for my astronomy class about that.
Well, hear me out. Spectroscopy is the study of an object's light on a light spectrum. Each color represents a temperature, mass, and luminosity. Astronomers use this to figure out what's out there.
Okay, slow down, future me. I have to write down word for word. So what exactly is a light spectrum?
Anywho, a light spectrum is a scale that when color shines through it, colors appear. Red, blue, green, poop, purple, YOLO. Wait. What is this? What does my paper say, poop? Poop's a color? Not funny!
Okay, what do colors have to do with space anyway?
Well, before we get to that, let me tell you first, brother from the same mother. There are things called wavelengths. Some are long, some are short. Now, infrared and radio waves we can't see. It's impossible, they're too long. Now, the opposite is true with X-rays, gamma rays, and ultraviolet lights. We can't see them because they're too short.
Okay, so if we can't see them, how do we know they exist?
Technology is amazing, man. Astronomers have different types of telescopes in space, such as the Spitzer telescope is an infrared telescope that picks up infrared wavelengths, the long wavelengths. This is an example of an infrared picture of the sun. The Chandra telescope does the short wavelengths.
What about the radio waves?
Go ask Mom, dude.
I can't, she's in Nepal.
Oh yeah, I remember that trip to Nepal. Good times, dude.
I have no idea what you're talking about. I haven't thrown a single party. Anyway, what else is out there?
Well, there's a thing called visible light. There are certain wavelengths that we can see. Human eyes can see 400 to 700 nanometers in visible light. This is visible light. The colors on the flower are visible to your eyes. And this, my friend, is fire. Oh my god, I'm on fire! Ah! That was a close call. But seriously, guys, work on your aim. My shirt. Anyway.
Dang, how'd you do that?
It's my secret, brother. You'll find out.
Alright, but tell me more.
Right. There are 7 types of electromagnetic waves. Each of them travels at the speed of light, 300,000 kilometers a second.
Wait. What do you mean by electromagnetic waves?
That's just a fancy science word for light. You have to understand there are different types of light. They travel at the same speed, but they have different wavelengths. If you put light through a prism, it'll refract it into individual wavelengths, showing Roy G. Biv. Red, orange, yellow, green, yada yada yada, you get the point. It does this from long wavelengths to short wavelengths. Red is the longest, violet is the shortest.
Oh, so light comes in different colors. It's kind of like paint that comes in different colors.
Yeah, man, they're related concepts.
Yeah, so then why is a plant, for example, green?
So the sun comes in through our atmosphere. It hits the leaf, and then the leaf takes in every kind of wavelength except the bright green color. It doesn't want to make green light, so it bounces it back, reflects it. Because it reflects the green light, that's what we see. We get the color green from the reflecting off of the leaf.
Yeah. What does this have to do with astronomy? When I see stars, they all look the same to me.
Okay, in order to understand this, we need to review one example. Sunlight. We have already said that sunlight, which looks whitish yellow, is actually made up of a bunch of different wavelengths or colors of light. Similarly, the light from the stars is a mixture of different wavelengths.
So, do you mean that if I point my telescope at a star, strap a prism to the eyepiece, I would get a rainbow of starlight?
Yeah, you would. In fact, that's exactly what astronomers did. What they found is that most stars have completely unique rainbows, so when they do this, they get a fingerprint of light. It's unique.
Yeah, so, what kind of stuff can you learn from stars from spectroscopy?
A whole lot, actually. But the basic starting point is this. The star's light spectrum tells us what elements the stars are made of.
Really? No, that's crazy. We're just looking at light, so how can we tell what elements are inside?
Let's use the light tube. So, remember when I told you about wavelengths and how the color red has an associated longer wavelength? Check this out. So, because I sprayed the fire with this chemical, it turns red. So this chemical has its own light spectrum. That's the light fingerprint for this chemical.
Oh, so you mean that if we look at a star through a telescope and see this exact type of red light spectrum, we know that it must have this exact chemical?
Exactly. And we know what chemicals are in them by looking at the emission lines, which tell us how much light there is in the wavelengths of the spectrum. For example, if a star has a light spectrum with only 4 strong lines, a red, a blue, a purple, and a violet, like this, this shows that the star contains hydrogen.
Whoa.
Hey, you're messing with my screen.
Alright.
Stop it. Elements emit different size wavelengths. Short or long, these wavelengths are seen as colors, and scientists use the wavelengths to determine what gases are in the stars and stuff like that. For example, lithium gives off these emission lines, and carbon shines light in these wavelengths. Taking pictures of the stars and nebulas and comparing the lights to the light spectrum helps scientists determine what the object is made of. This is how scientists know what the sun is made of without actually going there.
Dang, I didn't know that. That's really cool, actually.
For some practice, let's play a game.
Oh, I'm excited.
Ready?
Mm-hmm.
Which mystery gas is this?
Ooh, let's see. Oh.
Doesn't match.
Okay, let me try again. Once more, okay?
Good job!
Yeah!
On to the next one.
Oh, 2.
Now, which mystery gas is this?
Oh, definitely gonna have to go with hydrogen. Oh, definitely not enough colors. Yeah, okay, how about, helium?
Perfect! Good job, brother. You did good.
Thank you. Look, can I get back to, playing my video games now?
Alright, bro. Peace.
Yeah,
Tell
peace.
Mom I said hi.
No worries, bro. Crap, where's my controller?
Pick it up now!